Welcome to Module 9A, Signal and Amplitude Processing. After this presentation, you should understand what signal processors are used for, the four categories of signal processors, and the four basic types of amplitude processors. The function of signal processors is to alter some particular characteristic of audio. There are four categories of signal processors: spectrum processors, time processors, and amplitude processors. We'll consider the first three. Processors can be contained within another piece of equipment, such as a console, or they can be separate standalone units called outboard gear. Processors can even be software-based. Spectrum processors affect frequency characteristics of the audio. These devices include equalizers, filters, and psychoacoustic processors. Time domain processors affect the time relationships of audio signals. These include reverberation units and delay units. Amplitude or dynamic processors affect the dynamics of an audio signal. Dynamic processors include compressors, limiters, de-essers, expanders, and noise gates. Again, digital or amplitude processing consists of compressing, limiting, expanding, or gating. Let's investigate a little more. Compressors are amplifiers. That means they take an audio signal coming in and they produce an audio signal coming out. Now, the audio signal coming out can either be increased or decreased, or it can stay the same, what is called unity gain, or a gain factor of 1. Compressors, in addition to amplifying, compress the dynamic range of an audio signal. If you remember, the dynamic range is the range between the softest signal and the loudest signal. Compressors reduce dynamic range. Compressors are used to correct performances that have erratic audio levels. They can be used to smooth variations in different instruments or sound sources so that the audio can be heard. They help speech or singing to be more present, more upfront. And especially with radio broadcasts, compressors are used to capture the attention of the listener. Compressors have four basic controls which you need to know. The ratio determines how much compression is applied to the audio signal. The threshold is the audio level at which the compressor starts to activate. The attack time is how fast the compressor turns on, and the release time is how soon the compressor turns off after it goes below its threshold. The compression ratio is the ratio between the input level of the amplifier and its output level. For example, if we have a 2 dB increase in the input level, and the compressor only allows that to produce a 1 dB increase in the output, the compression ratio is 2 to 1. Here we see a compressor that applies a compression ratio of 3 to 1. Notice the difference in the amplitudes between the signals. There's much less difference between the softest signal and the loudest signal. If we increase our compression ratio to, let's say, 40 to 1, we have almost no dynamics left at all in the output signal. Graphically, this is what it looks like. Here we see a graphical representation of the input versus the output of the compression amplifier. If the amplifier is set for unity gain, it means that if the signal increases 1 unit coming in, there will be a 1 unit increase on the output. An increase of 2 units coming in will produce 2 units coming out, and a 5 unit increase on the input will produce a 5 unit increase on the output. This is with no compression. Let's apply some compression. Let's say that our increase is 2 units coming in, and it's 2 units coming out, still no compression. If we continued without any compression, the increase of the output would continue to follow the increase of the input. Let's allow the compressor to turn on at this point. This will be the threshold. We noticed that as the input increased 2 units, from 2 to 4, the output was only allowed to increase 1 unit. from 2 to 3. Likewise, if the input increased to 5 units, the output would only be allowed to increase to 3.5 units. So looking at the change, the input changed from 2 to 5 units for a total of 3 units, but the output only changed from 2 units to 3.5 units, or a total of 1.5 units. Therefore, our compression ratio is 3 compared to 1.5, which is equal to 2 to 1. We have a compression ratio of 2 to 1. Let's review the settings. The threshold is the level at which the compressor activates. The attack time is how fast the compressor turns on once it reaches the threshold. The release time is how long after the level drops below the threshold that the compressor stays on. Well, graphs can help us understand things, but what does this mean in real life? What does a compressor sound like? How can a compressor help us? Here I've recorded a sentence with no compression. Take a listen. Here's a waveform of my voice saying dynamic range. Let's add some compression. Going up to Audio Suite and selecting Dynamics because we're talking about dynamic processors, we'll select a compressor. Let's look at the controls we talked about. Let's set the compression ratio for about 5 to 1. That's pretty healthy. And for voice, we want a fairly fast attack time, about 1 to 2 milliseconds. The default release time of about 80 milliseconds is fine. And a control we haven't talked about is called gain or makeup gain. A compressor does its work in 2 stages. It reduces the dynamic range by first squeezing the higher amplitudes down closer to the softer amplitudes, and then it makes up the lost gain and brings everything back up to normal volume. We'll process that. Notice the dramatic decrease in dynamic range. The higher levels are much closer to the lower levels, and all levels have been restored to a good volume using the makeup gain. Here's what it sounds like. Here's a waveform of my voice saying dynamic range. And for comparison, once again without any compression. Here's a waveform of my voice saying dynamic range. Considering limiters as special-purpose compressors. Limiters are merely compressors with very high compression ratios, 12.5 to 1 and higher, even 100 to 1. So when dealing with a limiter, once we reach the threshold, the output level would not be allowed to exceed that threshold, no matter how much the input increased. Considering an expander. An expander also affects dynamic range, but it's the mirror of a compressor. In other words, the ratio is a reverse of the compressor's ratio. For example, the ratio of an expander might be 1 to 2 instead of 2 to 1. Often called a downward expander, an expander really increases dynamic range. It turns on when the signal drops below the threshold. Looking at an expander graphically, since it is the mirror of a compressor, we're looking at a decrease in signal. If the input decreases 1 unit, the output will decrease 1 unit. Likewise, 2 units. However, in this case, if we set the threshold of our expander at -2, a signal increasing 1 dB would be downwardly expanded and produce an output of -4 dB. Here the input changes from -2 to -3, or a -1 dB, and the output changes from -2 to -4, or -2 dB. So the expansion ratio is -1 compared to -2, or a 1 to 2 ratio. A noise gate is to an expander what a limiter is to a compressor. In other words, it's got a very high expansion ratio. When the signal drops below the threshold, instead of reducing the output further, the output is totally cut off. So a noise gate, once the threshold was exceeded, the output would drop to -infinity. Again, graphics can be nice to help us understand things, but how would we use an expander? Here I've recorded the same sentence, but with a lot of background noise. You can hear it, and you can see the background noise. Here's a waveform of my voice saying dynamic range. Let's use some downward expansion or some gating to get rid of that noise. We'll go up to Audio Suite, and let's select one of the expanders. Here we can see the downward expansion curve we were talking about. Let's pretty much work with the settings that are there, a ratio of about 3:1, a range of about -40 dB. Let's set our attack time faster, about 1 millisecond. And let's increase the release time a little bit. This will help prevent cutting off the ends of sentences. Now we'll process that. And notice on the waveform, the background noise has been gated out. You can hear the difference. Here's a waveform of my voice saying dynamic range. And again, notice that the waveform no longer shows the noise. This completes Module 9, Dynamic Processors. But before we continue, can you explain the functions and controls of a compressor, a limiter, an expander, and a gate? Can you explain the uses of these dynamic processors? If so, please continue to Module 10, Spectrum Processors.